Hello, my name is Liam, and I'm on Team Dihydrators. And from our name, you might be able to tell we made a biomass dryer. As you can see here, it's in our wooden box, but we'll get to more of that later. So our main objectives were that we wanted to dry the material by 15%, have no chance of ignition, and dries at a pretty quick time without losing a lot of heat, and make sure it's very safe with emergency measures. More on like our actual problem statement is we wanted to solve how to effectively dry biomass in like a personal container and have a very safe and controlled heating system.
Okay, so the constraints for our project is that we wanted to use less than 1200 watts of power. Our budget was $230. We wanted to keep it a portable size, so less than 2 feet by 2 feet and less than 30 pounds. And then we had 12 weeks to work on this.
Our dryer is powered with Arduino. Here is the circuit. We have two humidity sensors, one at the outlet and one down here at the inlet. And this light here just says how different those are so we can tell when it's drying. We also have a thermistor here to tell us the temperature because it's more accurate than the humidity sensors we're using. We have these two buttons here. This one allows us to choose the weight of the biomass that we're putting into the dryer, and this one allows us to time it. When we start the timer, this button will light up, as shown later. This has 3 different brightnesses. I'm gonna set it to the highest brightness because we are doing 100 grams right now. And the last part of the circuit is this relay, which we have hooked up to the heat gun and controls it with a PID.
So this is our box system. We made it out of plywood to contain all of our components and also prevent burns and make it easier to move around. This is our heat gun. We control it by using this relay, which shorts these 2 wires to turn on and off the heating elements inside of the heat gun. And then inside we have our piping system, which we made by JB welding these copper pipes together, which we drilled into with a manual mill, and we put them at this angle to promote airflow and also prevent sawdust from getting inside of the pipes and potentially back to the heat gun and causing fires. We also have a mesh basket to contain all of our biomass, and it just slides into place. You can put the lid back on, and then we can clamp it down. We also have a fan that's plugged into our Arduino to help exhaust the air out of the top. And now that everything's all set to go, I'll start the timer and then plug it in.
So now we'll take this apart and then weigh the biomass, which is about 48 grams of dry biomass or 100 grams of water removed. So these are our objectives that we completed and didn't complete. So our first one was avoid ignition with the holes in the pipe at angles. Then we completed 1 cycle in a decent amount of time, which is 100 grams of wet biomass in less than 20 minutes. Then we also calculated a thermal efficiency of 30% using the power in versus the dry biomass. Then we also did an LED system for safety for like the different temperatures. And then the uncompleted one we did was drying 1 kilogram in 1 cycle, which also led to us not being able to complete 1 kilogram in 1 hour.
For future work on our project, there are multiple things we would like to implement. One being an agitation system. We found in testing that not all the biomass in the dryer gets dried evenly. We believe that implementing an agitation system that could mix the biomass automatically within the dryer would fix this problem. We also feel like the container could also be bigger. Our goal was to produce a dry kilogram of biomass within an hour, and our current limitation is actually closer to 300 grams in an hour. This is because we went cheap with our container and we ended up with about $90 left in budget. So we believe that creating a bigger container for the dryer to be housed in and creating an automatic agitation system would allow us to produce more biomass and dry it better. To make the project more marketable, we would like to advance the electronics in the heat gun housing to conceal it from the user, making it safer and easier to handle.